Good morning. Starting out with a battle with my cat here. Good morning. Thank you so much for joining me in my shop. Me and Bert here for another day of working on this tube tester, except today's going to be a little different. I'm going to actually use the tube tester. Don't chew on that. I'm going to try to use the tube tester, test a bunch of tubes, and judge the operation of the tube tester, and probably I'm on my way to doing a calibration process through it. It's quite a complicated and long process, and I believe I did it. The last time I worked on this, but I'm not exactly sure. So I have a couple tubes. I've tested in a couple tube testers, and I'm familiar with how they should test out. So we're going to start by testing those tubes in here and see how it goes. That's right. That's if I can get Bert to vamoose. Yep, jump down. Nope. Yeah. Okay. Come on, Bert, let's go for a walk. Okay, let's test a tube here with this. Now, the last tube I tested was a 6SA7. I've checked all the controls are set appropriately for a 6SA7, and here it is. Let's turn the unit on. $102 volts. Let's go a little higher with this. Okay, so it's being supplied with 112 volts. We'll now do the line adjust. The one thing about this tube tester that's still outstanding is problems with the meter. So we're going to be watching this happen probably. So we'll flip it over to line adjust. Excellent. We'll do the adjustment. Ooh, that's not so good. Mine's jumping around, yeah. A little bit of dirt on the control. There we are. Success. Now somewhere up in here the meter tends to stick. Oop, wrong control. That happened there. It was lining up here before. Okay, well, we're still in the process of finding out what's going on here with this machine. Maybe there's no tube in here, so really, what would be doing? Oh. Reverse. I don't want to flip the reverse and power it too hard backwards. Okay, don't know what to say. Look at it jumping around there. Maybe that's the house voltage doing that. Should keep an eye on this meter over here. See if these two meters move the same. So this one's hardly moving because it's the scale. Yeah, I'm going to assume the little bit of movement here is actually the house voltage going up and down. Yeah, I can see this one move too. That's probably what it is. My own house voltage going up and down. Okay. Next, we flip this to, I suppose, test for the moment. Oh. How did that manage to happen? Next time it sticks, I'm going to examine very carefully what's happening here. So one possibility is the pointer is hitting the glass, and the other possibility is the pointer is dragging on the paper backing here. Neither one looks like it's the problem. Just from looking at it, you know, when I've seen this happen, the paper looks perfectly flat. It doesn't look wobbly, but you know, that's me looking at it. So if it gets stuck up there, we might consider it an advantage. So let's put the tube in. And you buy a 6.3 volts. Yeah. Don't stick your fingers under. Six SA7. This has been tested in a couple of testers, and it appears to be in, I guess you could say, 40% of its remaining life is still there, something of that sort. So the bias for this tube is 0. Flip on the bias and try to wait. Well, that's as 0 as it's going to get. That could even be 0. The meter may no. When the unit's off, the meter comes right down to the 0. So, okay, a little bit of bias left over. What can you do about that? We'll put this into current mode, and we'll read the current drawn by the. Oh, okay, that came right back. Let's go up there again. Yeah, I heard I almost like a click. Okay, everybody quiet. One more time. No. There's no sound. I thought I heard this banging into something, which would be far-fetched to begin with. Just a coincidence. So it's sticking at the same spot every time, but it's also coming down on its own now, which is a little bit of a relief. So we can measure the current on the 3 amp scale only, and how accurate would that be? So if you look at it on the 3 amp scale, we are getting, according to this, just under 250 milliamps. We're getting like 210 milliamps, and I'll bet you this tube is a 250 milliamp tube, and we're going to find out. Or does it say in the, I don't know, we'll look it up in here. This is a 6SA7. 6SA7. Right here. Heater voltage 6.3, current is supposed to be 0.3 amps, 300. Well, that just raises questions about the accuracy of the of this. I think that's really all it does. And now if I put it on 0.3, it's attempting to go all the way over. So that would suggest it is definitely, it's exactly right. Exactly. That's exactly as I can tell from all this. Okay. Now we're going to do the actual tube test here. And to do that, no, we should do the short test. I should have done it already. I did it before anyway. I know there's no shorts in here, but let's do it anyway. So we're watching the short light. Come on 2. And again on 7. And yeah, no shorts. Ready for the test. Oh, and what is it supposed to be? Hang on 1 second. I got to take a look at the guide here. 6SA7. This test should come up to 775. So we're on the B scale, or I'm sorry, we're on the 20K scale. 775 would be. I guess it means right up in here. If I had a wooden block under here, yeah. Okay, here we go. Oh my gosh. Oh, come on. Test. On. No way. Come on. Well, I was not expecting this. Other way. Oh, it's hot. Well. Did I set these right? I'm sure I did, but let's just go through them again. 6SA7. BGAG. BGAG. Nothing. No, the last one doesn't matter. 06432. 06432. 25100. 25100. I was hoping I had a mistake there, but I didn't. Bias at 0, but we can't get it there. So I would say that what we should try doing is the other half of this tube. Why would we do that? I don't think we will. I'm going to pull this tube out. I'm going to reset the machine for a 6SK7. That's this. Oh! So I have a policy of always checking the tube name before you stick it in. And I did not follow the policy, and of course I grabbed the wrong tube. Okay, that's good. That's really good news. Any reason I can't just plug this right in? No reason. Okay. Well, clearly, if you try to test a 6SK7 as a 6SA7, you're going to get a bad result. That's a bad mistake. Could do damage to a tube tester, I would imagine. Doing something dumb like that. No, this is definitely the 6SA7. Okay. You know, you got to make all the mistakes before you get it right. Short test. There's a position here that the switch can go in. It's just not labeled at all. Okay. I don't know what it means. So we're all set now. Bias is as low as I can get it. Check the line voltage. Oh, what's going on here? She's all over the place. Wow, this is really bad. I'm gonna crank this back because this is more likely correct. Well, it could be dirt and all kinds of controls under here, and somehow I'm flexing all the adjustments, and a little bit of dirt's causing all this stuff to happen. So, okay, let's test. Let's test. We no shorts. Here we go. Whoa, not on the line, Jeff. Not on the line. Why did the bias shoot way up there? Bias is set to 0. This bias control is reversed on my machine because I replaced this and I got the wiring reversed. So this is 0. Why did the bias fly right over? Flip the bias switch to 50 and then put it back on bias. Oh, there's a discharge. Flip it back to 10. 0, 0 now. Maybe because I had the wrong tube in there before. I was shorting some elements together. But anyway, I can set it to 0. Very good. Despite myself, I seem to be succeeding. Ready for the test? 7. Oh. A little bit of silence here. Why didn't that work? Tube's warm. Test, test. Did I do some damage having this one in there? Let's try this current thing again with the yeah. Okay, that seemed to behave quite normal. What am I missing here? There's just no result at all. Oh, come on! This is not expected. We know the meter is working because it's working. So what is it? Maybe any one of these switches might not have made contact. You would think it gets some kind of weird partial reading. This is a dangerous game I'm playing now. 0, 0. This is very unlikely to help. But you gotta do something here. No, none of these are in trouble. Well, that's mighty disappointing. We better try another tube. And I better go drink a little bit of coffee here because clearly I need more coffee. It's just 6SA7. We'll do the 6SK7. I'm going to put it right here. do that when I come back. Okay, so I've got this set now for a 6SK7 tube. Between the last video section and this one you're watching now, I got a phone call from a gentleman here in the city I live in. Do you fix vintage stuff? Yeah. Can you fix my 1972 Sony Trinitron color TV? No, probably not, no. But we had a long conversation about his beloved 1972 Sony Trinitron $1,800 television that he still has and would watch if he could. He has a DVD player, I guess with the appropriate outputs or something. He's got something anyway. He can watch old TV shows. No, I don't think I can fix it, the TV. Okay, so do we get warmed up here? Feels like it's warming up. So let's check first the line. Here we go. Line is high. We'll bring it down. That's nice. That worked really nice. I like that. Bias, it should be 1.7 volts. So we're on the 10 volt scale. 1.7 volts on the 10 volt scales down here. 1.7 would be just in this area here. 1.7. So, you know, I was going to say, so who knows if this is really calibrated properly? Well, I do. I'm pretty sure I calibrated this guy, but it probably could use another run. Okay, so now we've got the bias set. We should probably be looking for shorts right off the bat. Really, let's do that. 2, 7. We're in the test position. Test position for fun. Let's check the current flow in the heater. Okay, 0.3 right over. Whew. Meter comes up to exactly the same spot and stops. I rated the same spot. So it's not a case of the pointer sliding up against something and getting pinned, or it would stick. It would be hard to get it to come back. So it must be something that's blocking the movement. That's what I got. Okay, here we go. I'm in a good mood because this may be working. Here we go. Test that tube. Hot diggity dog. We got a test result. The test result is, I need to look at it. I forgot to check. 6SK7 should be 1250 on the scale. We're on the C scale. I'm sorry, we're on the 8K scale. 8K, 8. No. Okay, there I go again. No. Okay, don't know what that was. Whoever called me hung up before finishing the call. Okay, right, so we're looking at the reading here and thinking this is indicating that, okay, so wait a minute, this is the reject point, I believe, on this chart. Let me look again. Pretty sure 1250 is the reject point. 1250, so 1250 with a more better pointer. So looking at the scale here very carefully. So we're on the 10 scale down here. This would be 1. So 1250 would be up here. So this tube tester is saying this tube should be rejected. Let's check the sensitivity of the bias adjustment. So if it does almost nothing. So getting this a little bit incorrect won't change the reading. So this is actually giving a low test result to this tube. You reject this tube. But I've tested in other testers. This thing's got at least 30-40% of its life left, at least. Now why didn't the 6SA7 test properly? He says, asking an obvious question. Well, you just pull this thing out and it just goes to 0. Nice and warm. Okay, we're going to do the 6SA7 again. Yes, we are. I'm going to set the thing up with you watching. So that way, if I make a mistake, you can tell me. B, G, A, G. B, G, A, G. Okay, no doubt about that. And the last control doesn't matter. 0, 6, 4, 3, 2. 0, 6, 4, 3, 2. 2, 5, 1, 0, 0. 2, 5, 1, 0, 0. That's a 6SA7. Bias is 0. And that's all. So this is half this tube too. There's actually 4 potential tests for this tube, because it'll do 2 GM tests and 2 EM tests. That's 4 tests. That's a lot. Surely, I mean, any one of them should be enough, really, especially if you're doing go, no go. Okay, so we're set. So checking again, 6SA7. Yep, no doubt about it. Everything's right. Don't stick your fingers underneath the deck. Okay. Ooh, we don't want that there. That was bad. That was a bad move. And the meter didn't move at all. So I think we've already seen what the result's going to be. This tube failed. Did I grab a different tube on my bench? We'll have to test this in another tube tester. 6SQ7. That's pretty much the set, isn't it? Here's another one. Oh, this is an output 6F6 tube. Okay. Well, let's go through the process. Here we go. Shorts on 2. 7. Nowhere else. Check the line. Check the line. The line is for some reason low now. Like, what goes on with this thing that it does this? Why? Like, that's a big change. Oh, it must be the tube draw. Must be tube draw. Bias should be 0. Okay, it's a 0. It's as much of a 0 as we can get it. We read the current. Current looks the same as the other tubes. I won't bother pushing it all the way over. And we now perform the test. She's a dud. Okay, we're going to set now for the other GM test for this tube. B, G, G, G. Can I leave that in there? B, G, G, G. Well, for that I could. I get, some of these tube testers, as long as you're not doing the test, like pushing the test button, then that's okay. You can change these around. But in other tube testers, you cannot change these while the tube's in place. And which is which. So I don't know. 06041. 06041. Now it's up to you to tell me if I'm getting this wrong. Okay, so I'm counting on you now. 6SA7. Oh, there's a problem right there. No, it isn't. Yeah, the problem clearly is that I have not drank enough coffee yet. So 25100. 251. Oh, I already said it. What's going on here? I'm losing my mind. We are ready. So the tube is testing dead on this tube. Oh, I know what I'm doing. So, somebody better know what I'm doing. 06041. 06041. And I think the last numbers are going to be wrong. Should be 25200. Let's do the short thing just in case. I can't imagine it would be any different. Okay. Bias adjustment still 0, but did you see that thing just fly up there like that? Okay, it's exciting stuff. Here we go. Oh, now we're getting a reading, but it's falling off. Look at it fall off. She's fallen off down to nothing. Well, that's interesting. So we got one half of the tube saying nothing, and the other half of the tube saying a little bit of life, but you just drained it out of me. Let's see if we can drain it out again. It's drained out. So what little life was left on that tube, I drained out. We got to test this tube in another tube tester. Because last time I tested it just yesterday, it was good. We will do that after I imbibe some coffee here. Okay, let's turn our attention this way to this tube tester here, which I have set up for a 6SA7. It has 2 tests to do a 6SA7 in this machine. Just checking. JR7346. JR7346. 5. 2134. We're good. 3000 scale. Can you go? So this tester will do a GM test, same as the other one. The precise one on my bench, but it will not do an EM test for a tube like this. I think the point of view of this tester is, this is enough. Doing a GM test on a tube, that's enough. You're going to figure out if you can sell another tube to the poor TV owner. Based on that, you don't need to do 4 tests on a tube. That's really kind of crazy in a way. And what are you going to get? You're going to get four tests. You're going to get 3 say it's good and 1 says it's bad. What are you going to do then? Okay, short. Here we go. Short test. Okay, light is not staying on. That's good. Press P4 and 470 on the meter. So 470, just up to here. That's all I got to get to. Look at it. The other tester is a 0. Okay, we'll do the other half of the tube. JR5346 with a 7. 5346 with a 7. With a 7. I said it, but I didn't do it. 2134 P4. Here we go. Oscillator section. And it's also has to be above 750. So again, we're above here. So there's life in this tube. It's not a 0, but it tested as a 0 in the other tester. Uh-oh. 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 We'll have to test some more tubes in here. And I happen to have a couple of good ones here, like here's a 6SQ7. These kind of travel together, these guys. And then I've got this output tube, 6F6. Got another output tube, another 6F6. Got some miniature tubes we can try. So I got lots of tubes here. We'll try a few more and just see if this weirdness persists or not. So you could sell a lot of tubes with this guy. Okay, let's try this. This is a 6F6. The condition of this tube is unknown. I don't know if it's good or not. I imagine it's good, but I don't know. And 6F6 is a little more of a demanding tube. You see the size of it indicates it runs hot. If it runs hot, it means it's drawing a fair bit of current in the heater, and maybe even through the tube, a fair bit of current. So this one's a tough guy, I'd say. Tough guy. Okay, I'm going to flip this on. I've already set all of this. We will just pop this in. Just make sure this is 6.3. Yep. There you go. Okay, first, so I have to set the bias. I'll just read it off the chart here. 6F6, the bias is 1.7 volts. That's the same as the last tube, isn't it? So we'll flip this to bias. Oh, we've got to go to line first. We'll go to the line. That's pretty good. Okay. We're right on. Okay, we'll go to the bias setting. 1.6. 1.7, wasn't it? 1.7 on here would be, that's 1.5, 6, 7. 1.7. That's 1.7. Okay. The current draw on this is 0.7 amps. So if we put it to this 3 amp scale, it should come up to 0.7 on the 3. Right on. It's right on the money. Right on 0.7. Hey, something actually is right on the money. How do you like that? Okay, so we're ready now to perform the test. And the reject point for this is 1650. So we're going to be on the C scale, 8K scale. 8K scale. What did I say? 7. That's just here. That can't be that. Can't be right. Well, we'll see what happens. Here we go. Test this baby. So we're going up quite a ways above. Of course, that's the reject point. So you want to be above the reject point. So here on the 8 scale, we're 2.3. And 1.7 was the no, that's the bias. 1650. So, okay, 1650, and I'm all confused here. Let me put this on the hold switch here. Right, 8K scale. 1650 would be somewhere around where my finger is, and we're well above. So this tube is testing strong in this tester, although they don't give you the upper rating. So if it were brand new, would it be here? Would it be here? Would it be here? They didn't tell me. My other tube tester tells you that. Okay, so I think this guy would test as a good tube. We should look at the line voltage again. Bias? How'd it get way up there? Is that right? Get way up there. What did I do? 1.7 volts on the 10 scale. Yeah, what's supposed to be way down here? What's it doing way up there? Did I bump it? I thought I set this very carefully. I guess I did something stupid. I don't know. The line is close though. Back to the bias. The bias 1.7. That's the bias now. Correct? Test. Ooh, this was in the test position. That's the problem. Oh, that's what I did. Back to the bias. Okay, so I was in the process of making a mistake. Okay, there's 1.7 again. We're going to end up with the same test result. That's the line a little high. The test result is way up above the reject point. So this test is a good tube. Probably burn your hand. Yes, it is. Burn your hand. Hey, let's see if it's hot enough to burn my hand. The answer is yes. Okay, so we're going to do this in the other tube tester and compare it. If I were to actually, can I actually read the GM value? I guess that's what you're reading on here. So let's do that. Let's read the actual value. 8K. So this is saying it's 2400. 2400 micromos. 2400. I should write that down, but I can't right now. Good enough. 2400. We're going to try it in the other tester, the one I trust so much. Okay, so I've set up that tester. I'm getting the 6F6 tube out of here now. Still kind of warm. Put it in here. It's probably not that hot. Ooh, it's still hot. Still hot. Still hot. Okay, we'll give that a moment. 2400. Now, a tube does not have a specific GM. It has a GM when it's a specific GM when it's operated in a specific way. So, in that tester, it's going to measure the 2400, and it's got this reject number 1250. Different numbers over here on this tester. In fact, we can read them right here. 6F6. So 1260 is the reject point. That's quite similar to the other one. And 2000. This one gives the like new value. 2000. So if we did this on the 3000 scale, we'd expect a new one to come up here, one that we want to get rid of to come up about here, and this one's going to be somewhere in the middle, I believe. Okay, so it's got to be warmed up. We'll do the short check. Ooh, what was that? So this is showing a short on this tube. I didn't find a short on the other tester, or did it show up and I didn't notice it? So the general rule is don't proceed when you find a shorted element with the test. Either you're risking the tube tester or the test is invalid anyway. What should we do? It's definitely showing up a short here. 3. Another tube tester, but I'm not going to push the test button. We're going to stick it in another tube tester. This is crazy. Okay, here we go with another one, another tube tester. So the last tube tester, the one that's on the floor down there now, and this one are both GM testers, or transconductance testers. So the tube is cooled off enough I can handle it. Are we plugged in? We are plugged in. So I've already set this, but let's just double check. Absolutely sure. So 6.3 filament, signal level 2. The bias is 46 with an H. And the numbers are 27345, 27345, 0610, 0610. 34 meter sensitivity and F for the plate, and everything's ready to go. Okay, we'll put the tube in. Well, now would be a good time to give you the weather report. And I know you can't see the scale, so I'll do something when the time comes. Weather report here. A little bit of snow today, maybe 5 or 10 centimeters coming a little later today. And a little bit of snow tomorrow. But the next day, late Wednesday, early Thursday, they're looking at a big snowstorm coming through here with maybe, I don't know, 3 foot and a half of snow, or actually more than that, a couple feet of snow coming. Just under a meter. Okay, tube's got to be warmed up. Here we go. We're going to do the short test. This thing doesn't have a light. The meter shows the short. So what I'm going to do, I'm going to give you a good view of the meter itself. Bear with me. There we are. Now you can see the meter, sort of. If I could, I would block some light here. Okay, I can't do much better. Don't fall down. That just fell down. Talking to my camera here. Okay, camera. Just sit about like that. Okay, here we go. Short test. So this meter will pop up a little wee bit. That's okay. See it pop up? Doesn't mean a thing. We go along. Oh, there is a short showing up on setting number 1. So this one actually measures the resistance of it. So you can see it's a 5 megohm short. So it's hardly so it's enough of a short to light the light on the other tester. Let me wrap the tube a bit. So not a loose element type thing. Could have been like this right from day one. Come out of the factory with this in it. Maybe. I don't know. Wow, is this so critical? I think what I will do, there we go, just before I fall down, is I'm going to put it back in this tube tester and look more closely at the short. Oh, it's gotten too hot to touch again. Hey, now's a good time for a little bit of coffee. What's this? Looks like a Batman camera shot there. Funny angle. There we go. Coffee time. Okay, I've got the tube back in this tube tester. I've double checked again that the settings match the document, and they do. So the question is now, did I overlook a short indication on the short light? Because I was pretty quick with the short test. I really wasn't paying a lot of attention. I'm expecting the light to kind of leap out, but you can see that in the other tube tester, the light kind of sort of came on, and in the measuring tube tester it indicates it's not much of a short. So maybe the light came on and I missed it. Let's get you over there so you can get a good look at it. Okay. Let's perform the short test. Here we go. Everything's in the right positions. I think so. So that's the light without the light. Okay. Oh, that's 2. Okay, now that's normal. That's just one of the heater terminals. Should come on this one. Okay, we're back in the test position. I am going to put a better camera on that. We're going to do it again. I didn't see a thing happen there. Let's try this camera, looking right at it. Okay. Oh my gosh. Wires get tangled up in my shop here. Wow, we can't be looking closer than that. I'm going to have to focus this because, well, that's probably good enough right there. We'll just leave it like that. Okay, we're in a test position, and the light you see is, let me look. You know, that's extraneous light from under the machine. That's not the neon light. That's from the pilot bulb right next to it. So here we go. Position 1. Whoops. Oh, you know what? If the camera's going to do that, I am going to fix the focus because we don't want it changing. So just hang on a second here while I call up the dialog box for the camera and just take the focus off automatic and do this with it. Oh, that's much better. Okay, here we go. Look right inside the bulb now. Again, the light you're seeing is adjacent light. So here we go. 1, 2. That's the heater. 3, 4, 5. The little flash doesn't mean anything. 6. That's 7. That's the heater. 8, 9, 10. I'm laughing because, you know, the more tube testers you get, it's that same thing. You know, the guy with 2 watches never knows what time it is. It's the same thing happens with these tube testers. More than one tube tester, you never know what to say about the condition of a tube. Well, you just keep testing it until finally you can go, you see, you need a new tube. Sell one. Because I always say these tube testing machines were tube selling devices from the repairman's point of view. Okay. Well, I don't know, just continue on. We'll just pick another tube and make some more observations here. Where are we on the clock? I'm going to see how much time I've put in here before we continue. Okay, I've got time for another tube here. What we'll do is, I have another 6F6. Again, I don't know the condition of it. Oh, the key is broken off. So in a case like this, you can look carefully and see where the key was, and then you can carefully plug that tube in. So the key is pointing between these two. These two would be downwards. How do you destroy your tube tester? You push a tube in with no key and get it wrong. I've put the tube in. Oh yeah, that's alright. This thing is set for a 6F6. So we're raring to go here. Okay, line check. We've gone high. Guess maybe somebody threw a little more uranium in the nuclear station and got a little more power. Bias setting supposed to be 1.7. So we're on the 10 scale. 10 scale. That's right on. 1.7. Very good. Okay, we flip this I imagine it must be in the test position, and now we perform the short test. Okay, I'm looking carefully at this time. Okay, 2, yep. 3, 4, 5, 6, 7, yep. 8, 9, 10, back to test. I did not see anything happening in this. We could, for fun, see what kind of current is flowing in this tube. It's supposed to be 0.7, and if we look up here on the 3 scale, where's the 3? Way down here, 3 scale, and then we, yeah, well, actually it's a little under 0.7 on the meter. Okay, and we're ready for the test. Yeah, okay, test. And it's coming up similar to the other one. Again, the recheck point, I can't, was it 12? I can't remember what it was now. But here we're on the 8K scale, on the 8 scale, just under 2. So didn't the last one was 2400, and this one is just under 2, like 1900. Okay, get it out of there before it gets too hot. We're going to another tester from here. Just leave that like that. Okay, I've got this one put back up on top, so we'll start with this guy. It's 6F6, it's already set for 6F6. Stick it in again. Looking at the pins. Don't want to get this wrong. Just giving a moment here. Okay, look for shorts. Nothing being reported. P4, and the numbers are 1260, throw it away, 2000, clap your hands. You get to 2000. The 2400, so it's over 2000. Bravo 2. So this thing measured 26 on here, and when the top should be 2000. You know, how does this kind of stuff happen? Let's check bias sensitivity. So push the button and we'll wiggle this a little bit. We can see this makes a big difference. So if the bias control isn't quite right, why wouldn't it be right? 29. I mean, how accurate can this be anymore? Good too. Seem to be getting as hot as the other one. Okay, so the two testers agreed in this case that this is good too. Should we do? Let's do one. We'll do one more. Hey, let's do a little miniature tube. Why don't we try this? Do we know what this is? This looks like an output tube. 50 C5. Okay, we're going to test a 50 C5. I'll get the machine set up here. Okay, I think I've got it set here. Might be wise to just double check. 50 C5. And the tube is here. It is this one, isn't it? Yeah, 50 C5. Okay, I'll put it up there. 50 C5, no doubt about that. 50 volts right here. 50 volts for the heater. And oh, I'm looking at the okay. I started looking at the wrong line in the chart here and got frozen. BGAG. BGAG, and this doesn't matter. This only matters on an EM test. We're doing a GM test. 21651. 21651. 34 and a bunch of zeros. 34000. Okay, we're ready. 50 volts onto the tube here. Here we go. We'll stick it in here. Get in there. most of the time the instructions on tube testers is that you set them all up with the switch off, you put the tube in, then you turn the tester on. I think that's probably a better way to go. Okay, so line adjust, line check, go up a little bit. Okay, bias is to be set to, I better read it here, 1.5 volts. Okay, so we're on the 10 scale, 1.5, right there. Very good. I like this, setting the bias by a meter. Of course, I don't know if this meter's accurate yet. We'd have to do some more work on it. Okay, we'll flip it to the test. Now, how much current does this tube draw? 50 C5 should be drawing 150 milliamps. So we'll go to the 3 amp scale, barely come up, and then go to the 0.3 amp scale, should go straight up. Pretty well straight up. Good. Again, I don't know about the calibration on these things. Ready to test. Now, the test for this says, throw it out. Oh, shorts. You got to do shorts, and the shorts are going to show up on 2, 3, 4, and 5. Here we go. I'm watching the short light here. Oh, it's flickering. Oh, it stopped. Okay, flickering's usually not a problem. 2 comes on, 3, 4, and 5 on all those. 6 off, 7 off, 8, 9, 10, and we're back to 10. Oh! This does something. When you flip it here, I notice the light gets a little brighter, as if maybe you're turning the heater off in this position. I don't know. They didn't label it. So now we're ready for the test. 50 C5. 5600. So we're on the B scale. On the 20K scale. 20 is the very top scale here. 56 would put it somewhere around here, I think. Here we go. So if we are on the 20 scale, this is reading 2500. 2500, and the reject point on this tube is 5600. So this tube tester is saying this tube is way shot. It's way down. Interesting enough, it gives a second test for an EM test, and it says it's a more reliable test. Like the way they do is they show you the 2 tests on the sheet. One of them gets an asterisk. That's the one you should rely on. So let's do the EM test here. 50 C5. So to do that, we need to set B, E, B, D with a 6. B, E, B, D with 6. Okay. And then the numbers are the same numbers. The bias changes to 5 volt bias. 5 volt bias. So we go to bias. Well, I could go to line. Okay, that's good. Go to bias. We crank it up to. Hey, well, what's going on? How come it's backwards? What's happened there? We're in test position. We're just flipping at the bias, and this should go upscale. Didn't go anywhere. Ooh, what's happened here? Something funny happening? Funny haha? Did I just burn something out of this unit? Seems like quite a struggle, doesn't it, to make this thing work? Let's check for tube current again. Yeah, there's the tube current. It's definitely there. Test position. Hold still, tube tester. I gotta block here, yeah. It's the worst thing when this kind of stuff happens. You just don't know what to think. Well, maybe it's a dead tube. Son of a gun, it's not dead. What's happening? Bias. Can't set the bias. But we can test the tube. And it throws it right over. Who knows what it means? Let's move the bias while the test is going on. So I throw the bias really high, I can drag it down here. Yeah, and then once again, the bias control is backwards on my machine. So this is the high end, not the low end. Well, we'll have to test this in another tester. Now I'm forgetting. What did the GM test say? It said it was half gone. So now we're doing the EM test. We can't set the bias. But the bias needs to be set to 5 volts. I mean, it's on the list. The other thing is when you do the EM test, you know, it's a good and bad, or replace and bad. There's no numbers involved. So it's way in the good. Even if I drive the bias to the maximum. Or is that the maximum? So I got a 10 and a 50 scale, and I'm thinking this just changes the meter. But maybe not, because look, I'm on the 10 scale and I'm way up at the top. Let me experiment with this a little bit. So we'll flip this onto bias. Where's the bias? Yeah, there is no bias. Some experiment you're doing here. Yeah, that's the end of the experiment. We'll go back to test here, and we'll flip this on test hold. Get the result. Fool with the bias. The worst result you can get is still in the good, always in the good. I guess in a roundabout way, it's suggesting the tube is good. Well, we're going to do one more test in my other highly trusted tester, this one here. Okay, so let's just hurry along here. In fact, I'll stop and get it set up.